Hello and welcome once again. We're looking at solving systems of linear equations. We are going to use three different methods in this particular section. We're going to use the graphing method. We're going to use, my brush. We're going to use the graphing method, substitution method, and the elimination method. With the graphing method, of course, you would graph, and I used a website called Desmos to graph this. As long as the equations are written in this form, y equals, I plug these guys in here and I see what they look like. There is going to be either a point that they cross, or there's a couple of other weird cases where it's one line on top of another. We'll look at those, but you can see that the red line is this 2 minus x, and the blue line is the 2x plus 8. If I want to see the point at which they cross, I just hover my mouse over that point, and I can find that the solution to this, the place at which they both have the same exact point, is at x equal -2 and y equal 4. So I'm going to write that down for you. All right, so let's write this down as a coordinate point right here. We would have -2, 4. We could also write those answers as x equals -2, y equals 4. Writing it in point form, which is this guy right here, point form, automatically tells me that the x is the -2 and the y is the 4. So either way that you write those is correct. Now we can use the substitution method on these exact same equations, and we should get the exact same answer no matter whether we use the substitution method or the elimination method. So let's do that. Substitution method means that you substitute one into the other. So you write one of them as either x equals or y equals. And in this case, both of ours are written as y equals, which makes it pretty easy. If you have these two equations, y equals 2 minus x and y equals 2x plus 8, since y equals this stuff right here, you just plug that into the other one for y. So I'm going to be writing this as 2 minus x equals 2x plus 8. And then I just solve it as normal. I'm going to add x to both sides, and I will end up with 3x over here plus 8, and then a 2 over here. Subtract 8 from both sides. So let's do that. Subtract 8. Subtract 8, I'll end up with 3x equals -6, and then dividing both sides by 3, I'll get that x equals -2. And you're not finished here because you have to give them the whole point. And notice that we got x equals -2 with the other one up there. Now at this point, what you do is you take your x equals -2 and substitute it into either one of those. Whichever one you think would be easiest to do, you'll get the same answer no matter which way you work it. So I'll just say y equals, I'll plug it into the top one, 2 minus a -2. Computing that, I would get 4, which was what I expected. So got the same answer using that method. All right, let's use the elimination method. With the elimination method, you're going to write with x's and y's on same side. So let's do that. That means in this top one, I'm going to add x to both sides, and I'll get x plus y equals 2. On this second one, I'm going to subtract 2x from both sides, and I'll get -2x plus y equals 8. So now what I'm supposed to do is to look at these two and try to figure out which variable would be easiest to eliminate. So I'm going to need at this point to eliminate one variable. And you get to pick whichever one that you think would be easiest to do. So I'm going to move this up just a little bit. And looking at these two equations, I see that I have a plus y here and a plus y here. I think that if I were to multiply this equation on both sides by a -1, I would get something where my variable would be eliminated. So let's give that a whirl. I've got x plus y, and there are many, many ways to work these. I'm going to distribute this. 2x minus y equals -8. And then I'm just going to add these two equations. Watch that the y gets eliminated, and 3x equals -6. Dividing both sides by 3, I get that x equals -2. Of course, we already knew that, but what I'm demonstrating is that you can get the same answers no matter which method you choose. And then once again, you just take this -2 and you plug it into one of your two equations. I'm going to plug it in to that 2x plus 8 just to do something different, and watch me get the same answer. Whoops. -2 plus 8. Y equals -4 plus 8, and y equals 4. It doesn't matter which way you do it, you still get the same thing. So let's look at those two strange cases that tend to happen, because these are more familiar and they just require you to do quite a bit of practice. Now, the problems might tell you to use a particular method. So if they tell you to use substitution, do that. If they tell you to use elimination, do that, so that whenever you take your test, if you are told a particular method to use, you will know how to work all of the different ways. And really, some methods are good for one presentation of equations, and then the other methods are good for another one. So it's brilliant to know how to do all of them. And the graphing, well, the graphing isn't really a good way to get the answers, because if my dot had have been, let's say I looked at a line and it was somewhere around in here, I don't really know what that point is. It's not really on a crosshair, so I can't really tell what that is. I don't know if that's a half, 2/3, 5/6. So graphing is good for visuals, and it's good to get the point across and why these functions are working the way they are. But it's not really good to get answers because you don't really know exactly what they are with a graph. All right, we have another system of equations, and I'm going to graph them. In order to graph these, you're going to use your calculator, and you can push y equals on your calculator, and then it will give you something that looks like this, where you'll be able to plug in your equations in this area here. So the only way you can enter them, though, is for them to say y equals. So let's do that first. So we've got to make this first one 2x minus y equal 2 to look like y equals. So I'm going to move the 2x, which means I would subtract it from both sides. And I'll end up with -y, watch that negative, equals 2 minus 2x. Now, I don't need to know what -y equals. I need to know what y equals. So I've got to multiply both sides by a -1 to get rid of that negative. So I would have that y equals -2 plus 2x. So there's one of my equations. All right, let's find the other one. I've got 4x minus 2y equals 12. Lovely. I'm going to move the 4x. And then I'll have -2y equals 12 minus 4x. I'm going to divide both sides here by a -2. And then I'll end up with y equals, and I'm going to go ahead and do this division. 12 over negative 2 is negative 6 plus, because negative over negative is a positive, 4 over 2 is 2x. So here's my other equation. Those will be the ones that I will plug in to my calculator. So let's move this sucker over just a little bit. And then I'm going to say y equals negative 2 plus 2x. Nice. And then I go to my next y on your calculator, and I would say that y equals negative 6 plus 2x. And then I have that one graphed. Now let's look at these and see where are they going to cross. Let's get them on here. I do not believe they're going to cross because these lines are parallel. So where do they have an x and y the same? Nowhere. So I would say that the answer to this is no solution. So let's see how to write that because we have parallel lines. All right, with the substitution method, we need to write one of them as x equals or y equals. Since I've already written them as y equals, I'm going to do the same thing that I did before and just say that negative 2 plus 2x equals negative 6 plus 2x. Really convenient if you write them as y equals, then doing the substitution method is really nice. So let's see what happens when I subtract 2x from both sides. Oh my. I've got that this is negative 2 equals negative 6. This is not true. What this means is it doesn't matter what your x's and y's are. This is never true. So x's and y's don't matter. It's never true. And I would expect that because I said there was no solution and they're parallel lines. So what happens when you have parallel lines and you haven't graphed it and you're using the substitution method, you will end up with something that is not true. When you end up with something that is not true, you say, this isn't true, will never be true, there's no solution. So let's look at what happens when we use the elimination method. For the elimination method, I like for the equations to be written just as they were given. So I'm going to write 2x minus y equals 2 and 4x minus 2y equals 12. So I'm supposed to rig this somehow so that when I add or subtract these two equations to each other, one of the variables drops, meaning either the x's go away or the y's go away. So what about if I multiplied this top equation, and there are many different choices here that are correct and will get you a good answer, but I'm going to multiply the top by a negative 2. Because if I multiply the top one by a negative 2, I'll get a plus 2y, and then when I add, my y's will drop. So let's look at this. I've got negative 4x plus 2y equals negative 4. 4x minus 2y equals 12. Oh my goodness. This goes away, and it leaves me with 0 equals 8. Well, that's not true. When I end up with a not true statement, that means that there is no solution and the lines are parallel. So in either the elimination or the substitution method, if you go to solve it and you end up with some sort of statement that is not true, you would say, these are parallel lines. All right, now let's look at another strange case that might occur. All right, in order to use this graphing method and plug it into my Texas Instruments calculator, I have to make each of these equations need to read y equals. So let's solve each one and then plug them into our calculator. And sometimes this is the toughest part, using the calculator because he forces you to put it in this format. So we have this. I'm going to move the 4x by subtracting 4x from both sides, and I'll have 3y equals 2 minus 4x. I'll then divide both sides by a negative 3. So then what I'm left with is y equals, this doesn't really simplify, so I'm just going to write this as 2 minus 4x divided by negative 3. And that's what I'm going to plug into my calculator, and I'll show you that that's what I'm going to do. Because this is kind of a messy one. It doesn't come out beautiful like the others did. So let me do that 8x minus 6y equals 4. So I'm going to subtract 8x from both sides. And then I'm going to divide both sides by a negative 6. And I will end up with y equals, same as the other. I'm just going to write it like this and not really simplify it. And plug that into my graphing calculator looking just like this. So let's get that done. Okay, I'm wanting you to watch me plug this in because it's pretty exciting here. So I'm going to plug in. I've got the purple line drawn. That's the first one. And then when I plug in this denominator a negative 6, I want you to notice that it drew its line exactly on top of the other line. So if I eliminate this guy, watch. Notice he was exactly on top. That means that all of the solutions are exactly the same. If one line is exactly on top of another line, it means they're the exact same line. So all the same solutions work for both because they're the same thing. So let's write down how to do this. This means that all solutions, meaning all the solutions are the same. So your XYZ is going to want you to write that these are dependent lines because they're the exact same thing. So let's see what happens if you didn't graph it and you use, let's say, the substitution method. So substitution. Now, I'm not really crazy about using the substitution method for this one because I've got to write either y equals or x equals, and that makes this really kind of a messy problem. So I've already written that in a previous, whenever I was graphing it. So I'm just going to go ahead and use that top one when I had written down that y equals 2 minus 4x over negative 3. So I'm going to use that this is my y, and I'm going to substitute it in right here for that second guy. So let's watch. 8x minus 6 times whatever it is that I put in for y, and I'm going to put that right here. So that's going to be 2 minus 4x over negative 3 equals 4. Ugh. All right, so let's see what happens here. I've got this situation here, and I can make this problem a little simpler by just saying that 8x, and I'm going to go ahead and cancel this negative 3 into this negative 6 and make that a plus 2 times 2 minus 4x equals 4. And then I'll have 8x plus 4 minus 8x equals 4. And look, I've got 8x minus 8x, and then I have 4 equals 4. And this is true. It's always true. It doesn't matter what x and y's are. They're the same line. It's dependent. So it doesn't matter what your x's and y's are. These two things are exactly the same because basically they're the same line. And if I look at this second line, I can kind of see that he's double the first one, and he would end up being exactly the same. All right, so let's try this elimination method. All right, so I'm going to write my two equations. 4x minus 3y equals 2. 8x minus 6y equals 4. I'm going to multiply the top equation by a negative 2 so that my x's drop. All right, let's see what happens. So that's what I'm zoning in on, are those x's. I'm going to have negative 8x and 8x, and they're just going to drop. And I've got to go ahead and do all of my computation for everybody else. Got him written down. Write down this guy. And then I add. Zip, 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 0 equals 0. Hey, this is true. It's always true. It doesn't matter what my x's and y's are. It's always true because they are the same line, and I have a dependent set of equations, and all the solutions are the same. All right, so this was a rather long video. It was a lot to cover, and I think in the previous course that you took, all of this stuff was covered in an entire chapter. So if you are needing a little extra help with it, there is an entire chapter on solving these equations. I just went and looked it up. It was chapter 4. So if you go and click on the ebook that is in the tabs at the top, you'll get the entire ebook, and you'll be able to go to chapter 4 instead of just chapter 9, which is where we're at. All right. I probably will expect several questions, so feel free to email me, and I'm here to help. So please let me know what I can do for you. And y'all have a wonderful day. Bye.